taking a look at review guide 4 today in this video. We're going to do a little bit of a walkthrough and just kind of briefly talk about each question and give you a little bit of help if you need it on these questions. Notice at the top here, you're not allowed to use a calculator on these first 3 pages, and then you will be allowed to on that last page. So we'll keep that in mind as we work our way through these. Number 1 says, which of the following expressions have a value less than 1? Well, what will give you a value less than 1 is a negative exponent. So any of these that have a negative exponent are going to be a value actually between 0 and 1 is what it's going to give you, but it's going to give you a value less than 1. So let's go ahead and do a couple of these and see if we can come up with some examples here of what we're talking about. So this first one is 4 to the 11th divided by 4 to the 14th. When you divide powers, you keep the base the same and subtract the exponents. 11 minus 14 is negative 3. So this is 4 to the negative third. It has a negative exponent, so it's going to be a value less than 1. So A is one of our answer choices there that we want to select. B, here, you've got something to do up here on top before you divide. You always want to take care of your numerator completely and your denominator completely before you divide. So we got 3 to the 5th to the 2nd, a power to a power. That's, in that case, you will multiply those exponents. So that'll give you 3 to the 10th over 3 to the 4th. And again, we'll keep the base the same and subtract those exponents. 10 minus 4 is 6. So because that one has a positive exponent, we're going to go ahead and leave that one and not circle it because it's value more than 1. So you guys go ahead and finish out that and finish looking through those and see if you can find any other ones that will give you a value less than 1. Number 2 says graph triangle PQR with vertices, and it tells you the vertices there, and then graph its image after a transformation of, and it tells you this transformation. So you go ahead and plot these points on there. Go ahead and do that, and then you're gonna do one of 2 things. You can either come up with the new coordinates here after subtracting 6 from each one of these x coordinates and 4 from each one of the y coordinates, and that will tell you where to plot that. Or you may look at this and know what type of transformation this is. This is just going to be sliding this around. This is a translation. So if we're subtracting 6 from x, x tells us how we move right or left. If we're subtracting 6, we're moving 6 to the left. And then y tells us how much we move up or down. If we're subtracting 4 from y, we're going to be moving down. So you could just take each one of these points and go 6 to the left and 4 down and plot the new point there and graph it that way. So there's a couple different options you have for that one. If you need to pause in between these and finish the problems, I would suggest doing that. I'm just trying to get you a start, so you may need to pause it to actually finish the problem before you move on to the next thing. Number 3 says quadrilateral ABCD and is shown below. Quadrilateral QRST is the image of quadrilateral ABCD after the transformation. It shows here this is a rotation, and we're rotating this way with it after that rotation is applied. The question is, which angles have the same measure? Well, when you rotate something, you don't change, it's still congruent, you don't change its shape. So what you're looking for are corresponding angles. In other words, angles, they're in the same spot, just they've been rotated. So for example, B right here has been rotated over here and is now right there where R is. So these 2 angles are going to be the same measure. So let's see if there's a B and R combo right there. Yes. So the other way, or you could do this, is go through and check each angle pair and see if they're the same. But we can continue to do this here if we want to and say, well, A has been rotated now down here where Q is. So it's going to have the same measure. So you could find the AQ combo and circle that. Those will have the same measure. So see if you can figure that out, finish that out, and figure out what the other angle measurements are that will be the same. Alright, let's go ahead and take a look at number 4. It says evaluate 3 to the negative second. Write your answer as a fraction. Well, the first thing is this is a positive exponent. If we're going to evaluate a negative exponent, we need to first change it to a positive. So we're going to change 3 to the negative second to a positive by flipping it over, giving it a denominator of 1 and flipping it over. It becomes 1 over 3 to the positive second. And then our final answer would be whatever 3 to the second is will go in the denominator there, and that will be evaluated. Number 5 says simplify this right here. And the first thing we want to do on these, you consider the radical sign as kind of like a grouping symbol. You want to go ahead and do what's inside there first. So this is 2 times whatever the square root of 36 is. So times the square root of 36, which would be 6, plus the square root of 81. I'll let you guys figure that out, but then you're going to end up multiplying those and adding that together to get your final answer there. Number 6 says simplify. Looks like it's multiplying here, so you'll want to start with just the regular numbers and multiply 3 times -3. That'll give you something. And then you look for powers that have the same base. C squared times C squared. You'll write C to some power. You'll add those exponents together. And then D squared will be included there, even though there's nothing else to add over here that's another D squared or D with an exponent. You'll still include that in your final answer. So, let you guys finish that one out. Let's keep rolling here. Number 7 says, suppose 2 parallel lines are cut by a transversal. What angle relationships describe congruent angles in this context? So let's go ahead and draw a couple parallel lines here and some angle line that cuts through there. They want to know are corresponding angles congruent. So like this and this, do these two in the same position on the 2 lines. You decide there. A linear pair is when you draw a straight line and the 2 angles make up the straight line. They want to know if those would be congruent. Same side interior angles. So same side interior angles are like this one and this one. They're on the same side of the parallel line, or on the same side of the transversal, on the inside of the parallel lines. So you decide if those would be congruent. Probably should have drawn this a little bit bigger so you guys could see it better, but same side exterior angles like this one and this one here on the outside, are those congruent? Alternate exterior would be like here and here on opposite sides of the transversal on the 2 parallel lines, and then alternate interior angles like this one and this one. These would be alternate interior angles right there. So decide if those would be congruent. So you guys go ahead and decide on those which ones you would circle. Number 8, Wanda makes deliveries for a local store on Saturday. She has a choice of being paid $20 per day plus $1 per delivery, or $30 per day plus 50 cents per delivery. For what number of deliveries does she make the same amount of money with either pay schedule? So in other words, when would the amount of money be the same between the two? So we can write 2 expressions here and then solve this like we would just an equation. So the first side here is going to have she gets paid $20 plus $1 times a certain number of deliveries, or 1 times X. Now, we've learned that 1 with an X we don't need to write, so that's good to go there. Or $30 plus 50 cents per delivery, so 0.5 times X. So we have our equation set up now. We're looking for when they would be equal, so that's why we put an equal sign there. So you guys go ahead, the next thing you do here, you got variables on both sides. You want to go ahead and subtract those and see if you can finish that out from there. Okay, it's going to be a little tough without a calculator, but you guys can do it. Number 9 says solve this equation. Tell whether the equation has infinitely many solutions or no solutions. So it's one of the two. So you go ahead and do your distributive property here, and you're looking for either the sides being exactly the same as each other, that would be infinitely many, or when the variables cancel out, if you have two constants that are different from each other. If they're different from each other, then there's no solution. There's no way you could make them come out equal. Number 10 says find the measure of the missing angle. So looking for this angle right here. This is the exterior angle theorem. It says that the exterior angle is equal to the 2 remote interior angles combined. So this plus this equals this. So you got to figure out what's left over here. If this is 45, what's left over here to equal 140 altogether for that. Number 11 wants you to sketch the trapezoid in the coordinate plane after it's reflected about the y-axis. So one thing you could do here, if you're doing a reflection across a point there, if this is across the y-axis, all you got to do for a reflection is count the same number of units away for each one of these vertices here. So if this point here is 2 units away, count 2 units this direction from the line of reflection. We can kind of put a point at each one of these so we know how many points we're moving. We're moving a total of 4. So then we can go to this one here, which is 4 units to the left. We'll go 1, 2, 3, 4 units to the right. And that makes up that first line there. That's that line right there, right? So continue to move those other points the same units away and see if you can finish that out. Number 12 says graph triangle DEF with vertices, and you can put those points on there. Then graph its image after translation of a rotation 180 degrees about the origin. So you're going to graph that triangle on there. If you remember the rule for 180 degree rotation, it's just to change everything to the opposite. So you're going to write a D prime, E prime, F prime, change all these to their opposite, and you should be able to plot that on there and get that rotation 180 degrees correct there. Number 13 says, a figure is dilated by a scale factor of 5. If the center of dilation is the origin, what is the image of a vertex located at 2, 8? Well, with scale factors, and you're given original and looking for a new, all you got to do is multiply the coordinates by the scale factor, and that will give you your new coordinate there. Number 14, what are the coordinates of the image of the point -6, -2 after a 90-degree rotation clockwise about the origin? Well, if you guys remember, 90-degree clockwise says that you're going to switch the two coordinates. So it's going to become, instead of -6, -2, it's going to become -2, -6. And if I'm going clockwise, then I change this one to its opposite. So this is not my final answer here, but it's close. You're going to change that to its opposite. You guys come up with the final answer there. Number 15 says, write 0.39 as a fraction in simplest form. So the thing that we do, if you remember, with any decimal, is we take whatever comes after the decimal, and that's our numerator. Oops, 39. With a terminating decimal like this one, we just name the place value of the last digit here. So this is in the tenths, and that's the hundredths. So this is 39 hundredths, or 39 over 100. So the only thing you guys have left to do here is to decide if this can be simplified by dividing both 39 and 100 by the same thing. Is there something that both 39 and 100 can be divided by? So you figure that out and see if that can be simplified there. Number 16 says, write 7/25 as a decimal. You're not allowed to use a calculator here, so you have to do long division. Remember, top dog goes in the dog house. So we'll put 7 on the inside with some decimals here. Some zeros after the decimal. And 25 will go on the outside. Put a decimal point there. And you're going to begin by trying to put 25 into 7, which can't be done. And then 25 into 70. So you guys figure that out, how many times that goes in there. Multiply that out. You guys are going to finish your long division there. Number 17, if x equals 20, what is the value of y? So we can go ahead and put in 20 here. This is the triangle sum theorem that says all the angles on the inside of a triangle always equal 180 altogether. So we know this one right here, a perfect corner, is 90 degrees. So 90 plus 20 plus our unknown here, y, equals 180 altogether. So you guys finish that out and solve that and figure out what y is. 18 says, graph triangle DEF with vertices here, then graph its image after rotation 90 degrees counterclockwise. Okay, so you're going to graph it on there, and then for each one of these, a counterclockwise rotation, if you remember, the rule is you switch the two coordinates, but then you change the one on the left to its opposite. So like, for example, this one here, 0, 3, D prime, would become 3, 0, but then I'll change this to its opposite, the one on the left to its opposite. So D prime will become -3, 0. So you guys do the rest of them, plot the original and after it's been rotated 90 degrees. Number 19 says, state if the number is rational or irrational. When you're talking about square roots, perfect squares are rational. Non-perfect squares are irrational. So you look at this to decide if this is one of our perfect squares or not. If it is a perfect square, you'll write rational. If it's not, you'll write irrational. Number 20, identify this as rational or irrational. When you take the square root of a fraction like this, all you got to do is take the square root of the numerator. So these are both perfect squares. You guys go ahead and figure out what the square root of 169 would be, and no calculators. So it's a whole number, and the square root of 64 is a whole number as well. So you just got to come up with those new numbers after you take the square root of each of the numerator and denominator and decide if that will be rational or irrational. 21 says a square kitchen floor has an area of 91 square yards. Estimate the length of one wall to the nearest tenth of a yard. So if you know the area of something, you want to know the length of one wall, one side, and it's a square, all you got to do is take the square root. So this is about estimating square root of 91 in particular here. So to do this, there's a couple different ways, but to do this, one way is to come up with the two perfect squares on either side. So either way you do this, you got to come up with the two perfect squares on either side, which is 81 and 100. Square root of 81 is 9, and the square root of 100 is 10. So this is going to be somewhere between 9 and 10. I'm going to do the long division method here. Long division says that I can write a fraction for this. The numerator is the distance between the smaller perfect square and the one in the problem, between 81 and 91. So that's a difference of 10. In other words, we're 10 on our way to from the first perfect square to the second. The denominator is the difference between the smaller perfect square and the larger perfect square. From 81 to 100, the difference is 19. So you're going to use long division, and I'll set this up for you again. Top dog in the dog house, like we talked about with the other one. 19 on the outside. You're going to go ahead and start, get this 10 in the way here. You're going to go ahead and start dividing this by taking 19, and we know our whole number already is going to be 9. So 19 into 100, and figure that out, and you go from there and see if you can figure out, just to, it says the nearest tenth of a yard. It's just two numbers after the decimal, and then round to the nearest tenth there once you've got two numbers. So go ahead and do that. 22, a very small dust particle has a diameter of about 0.004 inches. Most cells of living organisms has diameters of 4 times 10 to the negative 4th inches. Which is larger, the dust particle or the typical cell in a living organism? Justify your answer. Well, to justify my answer, what I'm going to do is I'm going to take this, I'm going to change it to standard form. 4 times 10 to the negative 4th. Right now, my decimal will be right after here. This tells me, with a negative exponent, I'm going to be making this number less, and I'm going to move the decimal 1, 2, 3, 4 spaces and fill in the empty spaces with zeros. So that's that's one of the living organisms there. So that's 0.0004. So now you got to decide between this one and this one, which one is the larger, which is larger, the dust particle or the typical cell. So you take a look at those and decide. 23 says the triangle shown is translated left 5 units. So you're going to take this and translate it left 5 units. I don't think you have to graph it. It wants to know, write an algebraic rule for this transformation. So you're going to do x, y to something that happens to x, so x plus or minus something, and something that happens to y plus or minus something, if there's any change there. And then what are the coordinates to the final image? So after you apply this rule, what are the new coordinates you come up with? So you got to come over here and pull these coordinates off here for the originals, and then apply this rule to get the new coordinates. It wants to know if the triangle is congruent to the original. So you write yes or no for that. 24 is another exterior angle theorem. I'll get this one set up for you here. It says that the exterior angle, which is 15x plus 5, is equal to the two remote interior angles combined, the two that are not right next to it. So 80 plus 6x plus 6. So you guys are going to solve this equation now. Find a value for x. First thing you got to do here is you get a couple like terms on this side that should be combined. So that's the first thing you'll do. But you'll solve this for x, and then you'll plug in your value for x. It wants ydc. You'll plug it in right there, and you'll get your value there for that angle. All right, we're almost done. We're to the back side, and on this side you can use a calculator. Most of these are Pythagorean theorem problems, so I think I don't know. I think we're gonna try to stop here. There's some good questions to go over here, but we're just getting kind of late on time, and we've done a lot with the Pythagorean theorem lately. You do have this equation you need to solve, and I would get rid of the fractions first. So to do that, you'll need to multiply by a common denominator of 4 and 5, and everything in the equation will get multiplied by that. So in other words, if you count by 4s and count by 5s, you want to look for the common number that they share. So you look between these, find something they share, and multiply everything in the equation by that. And then you're going to solve that equation, solve for b in that. So you guys can work through that. I think you guys can maybe figure out the rest of these on your own. These are, like I said, some Pythagorean theorem problems. Maybe we'll have a chance to talk about them in class a little bit, but we're going to stop there.